All right, the first thing that we need to talk about is when we talk similar polygons are pretty much everything that we do with similar polygons has to do with ratios. So we need to know what a ratio is. Well, a ratio is just a way of comparing two things using a fraction. So we write A over B. You can also write A to B, or just use the word A to B. So we'd say 2 to 1, 2 to 1, 2 to 1, 3 to 5, something like that. Usually, we use the same units, but not always. So if we have a map, for example, the scale on the map might be 1 inch equals 1 mile. So the ratio is 1 inch to 1 mile. So the units are not the same. But inch and mile are both units of distance. So you probably wouldn't say 1 mile equals 3 cups of sugar, something like that. That wouldn't make as much sense. But when you talk about your car, you talk about how many miles per gallon it gets. So miles to gallons. So sometimes they are different units. But usually we use the same units. And usually we reduce the fractions. So we don't say 2 to 4, we say 1 to 2. We'd reduce that fraction. We can also have extended ratios. Extended ratios compare 3 or more things. So we could say, for example, A to B to C. So you might say 4 cups of flour to 1 cup of sugar to half a cup of butter. And this extended ratio gives us various regular ratios. We have the ratios A to B, A to C, and B to C. So we can compare the things in pairs with a ratio. All right, folks, cell phones in here, please. All right, so let's look at an example of a problem that involves ratios. So we could have 2 complementary angles. So before we write anything else, complementary, what does that mean? Yeah. They add up to 90 degrees. With the ratio, with a 1 to 3 ratio. And we want to find the angles. Well, let's draw a picture. We know that the 2 angles add up to 90 degrees. So there's my 90-degree angle. And we're dividing it into 2 pieces somehow. So in math, if we don't know what something is, what do we like to call it? X. So one of these angles is X. if the angles are in a 1 to 3 ratio, this angle is 1x. What is the other angle? 3x. So those two angles are in a 1 to 3 ratio. And we know they add to 90 degrees. So 3x plus x has to equal 90. So 4x equals 90. Divide by 4, and x is 22.5 degrees, and 3x is 67.5 degrees. So this one's 3 times bigger than this one, and they add to 90 degrees. All right, questions? Okay. The next thing that we need to talk about is, well, we're going to compare ratios. And to do that, we use a proportion. Proportions are equations between two ratios. So we did an example on the board, our opener. So I'm just going to 3 to 8 equals 5 to x. That's a proportion. We have some equation that has two ratios. And we solve them by cross multiplying. So this one would be 3x equals 40. 3 times x, 8 times 5. Divide by 3, and we can say x equals 40/3. And that's fine for the answer. Yes?
So you cross-multiply them to get the equation, and then you do the equation?
Then you solve the equation to find the missing.
Will it always come up in a fraction?
Not always. Usually it does, though. Let's look at another example, because I want to show something, a mistake that's easy to make with proportions. Sometimes we have a proportion that looks like this. So we have some, not just x, but some x plus something, some expression in one part of our proportion. So what I suggest that we do in this situation is put parentheses around that, so you remember when you multiply to distribute correctly. So now when I cross multiply, I get 6 times the whole thing, x plus 3, equals 12 times 5. 12 times 5 is 60. So a lot of times if you don't write the parentheses, when you write the 6 times x plus 3, you just do the 6 times x, and then you get the wrong answer. So now we can distribute. We have to distribute here, and we get 6x plus 18 equals 60. Subtract 18, and 6x equals 42. Divide by 6, and this time x equals 7. So that the parentheses, a lot of times, if you forget to do the parentheses, you will forget to distribute correctly. All right. Sometimes when we have proportions, we have something like this x plus 3 in both parts of the proportion. So let's look at an example of that. And that's going to lead us into the quadratic formula. So let's say we have x plus 3 over 3 equals 2 over x plus 2. I'm going to put my parentheses around there so I remember to multiply correctly. Now I'm going to cross multiply x plus 3 times x plus 2 equals, multiply those, 6. Well, now I have these two parentheses multiplying each other. What do I have to do when I have something like this? I have to FOIL. So let's write it out over here. So when we multiply this out, our little acronym to help us remember is FOIL. If you don't remember it, write it out. F means first. So we're multiplying the two first things. X times x. X times x is x squared. O is for outside, so we're multiplying the outside things. X times 2. 2x. I is inside. 3 times x. 3x. And L means last. The last things in the parentheses. 3 times 2. 6. And then we add all these together. So this is x squared plus 2x plus 3x is 5x plus 6, and that equals 6. Anytime you have an equation with an x squared, an x, and a number, you should get everything on one side of the equation and a 0 on the other side. Anytime you see an x squared, an x, and a number, that's what you want to do. So I'm going to subtract 6 from both sides. Wait, I wanted this to be, sorry, I wanted that to be a minus. That should be a minus. So this should be a minus, and that should be minus. So now when I do my inside, when I add these together, I get a minus x. Otherwise, the problem wouldn't come out the way I wanted it to come out. There we go. Now we're going to subtract 6 from both sides. And I get an x squared minus x minus 12 equals 0. Anytime you have an equation with an x squared, an x, and a number, and it equals 0, to solve it, we either have to factor. We've done that a lot in our algebra reviews, or we have to use a quadratic formula. This one factors nicely. We'll talk about the quadratic formula in just a second. So to factor, I need my two parentheses. Yeah, Debbie?
Why is it -6?
I wanted to get a 0 on this side, so I subtracted 6 from both sides. I subtracted.
You always want to get a 0 on the other side.
If you have an x squared, an x, and a number, you always want to get a 0 on the other side. And we need two numbers that multiply to negative 12 and add to negative 1. So two numbers that multiply to 12 that are 1 apart. How about 3 and 4? And to get a negative 1, we need a negative 4 and a plus 3. And now this tells us the only way that two numbers, this is a number, this is a number, the only way they can multiply to give a 0 is if one of them is 0. So that says x plus 3 equals 0, or x minus 4 equals 0. Subtract 3 from both sides to get x equals 3, or add 4 to both sides, x equals 4. So when I get an x squared, an x, and a number equals 0, usually you get two answers. Sorry, this should be a negative 3. If you can't factor, or you forget how to factor, the numbers are weird, or it's impossible to factor, then we have to use the quadratic formula. So questions here before we go on? All right, so let's talk about the quadratic formula. Do a little quadratic formula review. So if we have an equation where we have some number in front of x squared plus some number in front of x plus another number, and that equals 0. So you have an x squared, an x, and a number, and it equals 0. That's a quadratic equation. Quadratic means second power. The quadratic formula gives us a way to figure out what x is. X is negative b, plus or minus. The plus or minus is what gives us our two answers. The square root of b squared minus this whole thing, 4 times a times c. And we're going to divide everything by 2a. So a is the number in front of the x squared, b is the number in front of the x, and the c is the number that's by itself. We plug these numbers into this formula, calculate, and we get our answer. So let's look at an example. And we'll practice some of these on whiteboards after we finish today. 2x squared minus 10x plus 11 equals 0. So we did some kind of work, and this is the equation we need to solve. So we have an x squared, an x, and a number equals 0. That's our quadratic equation. We can use the quadratic formula. This number is a, just the number. This number is b, just the number. And this number is c. So we'll plug that into our formula. Quadratic formula tells us that x equals negative 10 plus or minus the square root. I'm going to write out everything just exactly how I would plug it in here. Negative 10 squared minus 4 times 2 times 11. This is all multiplication here, and we're going to divide that all by 2 times 2. So I wrote this out exactly like this, just to show exactly how it goes into the formula. So we get x equals, well, negative 10 is positive 10. Plus or minus negative 10 squared. When we square a negative, we always get a positive. 100 minus 4 times 2 is 8 times 11 is 88. And we divide that by 4. So this is x equals 10 plus or minus the square root of 100 minus 88, 12, divided by 4. 12, we've been practicing simplifying radicals. We can simplify square root of 12. This is 10 plus or minus the square root of 4 times 3, divided by 4. And I can split these two up. Square root of 4 is just 2. The 3 stays inside. Square root of 4 is 2. Square root of 3 divided by 4. And then I can think of this as two fractions. This is 10 over 4 plus or minus 2 square root 3 over 4. And I can reduce these fractions. So I divide everything by 2. So my two answers would be 5 halves plus or minus the square root of 3 halves. And to get one answer, I'd do 5 divided by 2 in my calculator plus the square root of 3 divided by 2. my second answer would be 5 divided by 2 minus the square root of 3 divided by 2. That would give me my two answers. Yes?
Are you going to want us to actually solve it, like
Some,
plus or minus, or can you just leave it?
you can leave it like that.
Okay.
Unless it's something like the side of a triangle, then you don't want a negative for the side of your triangle. So you do it out and see if one of them turns out negative.
Okay.
And you won't always get a square root of something there. A lot of times it'll turn out to be nice whole numbers. All right, we'll do some more practice with this in a little bit, but I just wanted to remind us about the quadratic formula. All right, now this next section is actually 7.2 about similar polygons. So far, we have talked about shapes that are congruent. And what was the way that we talked about congruent, our everyday way of saying things, how we knew when things are congruent? They said they were the same something and the same something else. Can a circle be congruent to a square? No. Does it have to be the same shape? And what else to be congruent? Same size. So congruent meant same size, same shape. Similar figures are the same shape, but not necessarily the same size. So rectangles can be similar to rectangles. Rectangles can't be similar to trapezoids. They have to be the same shape, but not necessarily the same size. But their sizes are related in a particular way. Now our symbol is one squiggle. And that one squiggle means is similar to. Polygons are similar if corresponding angles are congruent That's how we make sure they're the same shape. Corresponding angles have to be congruent. And corresponding means the big angle matches with the big angle, the medium angle matches with the medium angle, small angle matches with the small angle. And corresponding sides are proportional. And proportional means the same ratio. So we check the ratios of the sides, big side to the big side, medium side to the medium side, small side to the small side, and they all have to have the same ratio for the two shapes to be similar. Now this proportional piece, that's going to be our key way to solve problems in Chapter 7. In Chapter 7, when in doubt, write a proportion. Pretty much everything we do in Chapter 7 is going to have to do with solving proportions, because we're comparing sides using ratios. So that's going to be our key way to solve problems in Chapter 7. All right, so let's look at a couple of similar polygons and talk about how we end up writing proportions. Now, what we're going to do in this chapter is similar to what we did in previous chapters. We're going to talk about polygons, and then there are shortcuts to figure out if triangles are similar. So I'm going to say yes. Yes. All right, I'm going to say this is A, B, C, D, and G, H, I, and J. And I'm going to say that A, B, C, D is similar to G, H, I, J. This thing is called a similarity statement. And the similarity statement, just like with a congruence statement that we had before, tells us how the pieces match up. So this tells us, because of this, angle A matches with angle G. So angle A is congruent to angle G. So if I mark that here, those two angles would be congruent. It tells us that angle B is congruent to angle H. So the second angle matches up with the second angle. So those two would be congruent. And we could keep writing G, and I'm just going to say etc. So if I marked up my figure here, I would have that congruent to that. C is congruent to I. And D is congruent to J. So the similarity statement tells us those angles are congruent. We also know that if polygons are similar, that the corresponding sides are proportional. What that means is that the ratio of AB to GH, the lengths of those sides, is the same as the ratio of BC to HI. That also is the same as the ratio of DC to JI, CD, JI. And that is also the same ratio as AD to GJ, these two sides. All of those are the same ratio. The sides are proportional. Any of these is called the scale factor. So if that ratio is 2 to 1, that tells us that this polygon is 2 times bigger than the smaller polygon. If the ratio were 3 to 2, that would tell us this polygon is 1.5 times bigger. And you can have other kind, 5 to 7, 10 to 19, something like that. So that tells you how the sizes of those two polygons compare. And we call that the scale factor. So if you have a legend on your map, 1 inch equals 200 miles, that tells you the scale factor between the map and the actual thing that the map is representing. It tells you how much bigger the real world is than the map. All right, questions? Okay, let's look at some examples. So I'm going to draw a couple of shapes here. And I'm going to mark these angles. And I'm going to say this is 10 and this is 4. Whoops, I did it backwards. This one is the bigger one. So this is 10 and this is 4 and this is 16 and this is 6. And we want to know, are these similar? All right, first off, are they the same shape? Yeah, are all the corresponding angles congruent? Yeah, all the corresponding angles are 90 degrees. What shape is this? Rectangle. They're two rectangles. If we had just some odd-shaped four-sided figure, we would have to make sure that all the four corresponding angles were congruent. That would mean it was the same shape. Well, now we need to see if the sides are proportional. So I'm going to make ratios of the sides. So what side would I compare to? So I'm going to say angles congruent. And we're going to look at the sides. So what side am I going to compare with the 16? 10. 16 over 10 is, I can reduce that to 8 over 5. Divide everything by 2. And then I'm going to do 6 over 4. And that's going to be reduced to 3/2. Those are not the same. Not the same, so these shapes are not similar. And if we had some odd-shaped, four-sided shape, we would have to check the ratios of all four of the corresponding sides and make sure all four of them were the same before we could say that those two shapes were similar. All right, questions on that example? Okay, last one. So sometimes we want to decide if things are similar. Sometimes we use the fact that things are similar to solve a problem. So I'm going to say these two polygons are congruent. And let me draw our picture. All right, here's W, X, Y, and Z. And here is R, S, T, Z. I'm going to say this is 16, and that's X, and that's 24, and that's 20. We want to find X. So the problem tells us that those two polygons are similar. So we know that corresponding sides are proportional. So we're going to use that to help us solve our problem. So we're in chapter 7. We're trying to solve a problem. When in doubt, what should we do? Write a proportion. So let's compare the sides. What side am I going to compare with X? 20. That's the short side. X over 20. That has to be the same as, since these are similar, 16 over 24. There's our proportion. And I cross multiply to solve this. 24x. 20 times 16 is 320. Divide by 24. And x is about 13.3. What if I did this problem and I got that x was 25? What would that tell you? It would tell you did something wrong, because this is shorter than this, so this is going to need to be shorter than that. So if you're solving for a shorter side and you get something that's bigger than the thing you're comparing it with, then you've made a mistake somehow. You might have set up your proportion wrong, you might have done your multiplication wrong, made some kind of arithmetic error. That's a way that you can check to make sure your answer makes sense. All right, questions there? Okay. Homework is in 2 pieces. This one, the first one, is the similar polygons homework. And this 439 is some practice with the quadratic formula.